yesterday. It's just talking about the relationship of how 0.7 came and 1.6 came. But all we're going to do is start with the easy stuff. Let's start with the calculator here. To 4 decimal places in your calculator right now, please enter tan 35 and tan 58. We'll start with Charles and Hunter. So tangents in the middle of your calculator. You got your calculator, Hunter? Yeah, okay. So tangents, right? Okay, if you don't, then we'll skip you. You're putting in your calculator tan 35 and tan 58. Make sure your calculator's in degree mode. Don't have it? Okay, fine. Second. Second. Said, okay, Charles, what's this one? Shh, this is what I'm talking about. Shh. Okay, 0.7002. Okay, Hunter, what was this one? 1.600. What's the last one? 3? Okay, no, it's good. Okay, sine 35, Ross. 0.5736. Okay, Kyle. 8191. 92, I think, yeah. Round. Okay, Calvin. 0.8480. Okay, Steph. 0.5. Like that? Okay, good. Okay, so yeah, this is using the calculator piece. Using the calculator piece is generally pretty easy. Okay, so that's good. We'll get that locked in. Question?
If I put 0, would I get that wrong? Put 0 point.
No, that's okay. 0 point or just point's fine. It doesn't matter to me. Okay, with respect to the diagrams at the top of the page, which ratio of sides is represented by each ratios in A? So what they're saying is when you do sine 35, what would that be in terms of the picture? So like sine of 35 above is side AB compared to side OB. I can't bring my picture up there, but can you see what I'm saying with the triangles there? So sine 35 opposite is AB to OB, which is the hypotenuse. Cos of 35 is OA over OB. That's for diagram 1. Sine 58 in diagram 2 is AB over OA. OB, sorry. Okay, and then lastly, cos 35 is OA over OB. Oh, yeah, thank you. Thanks, Teague. So it's the same ratio, but they're different triangles. And so I want you to understand, maybe I'll give this to you, and this will help you guys better for later. Okay? We need to understand this, and the thing I was talking to Han on the board for a long time is that the hard part is the fraction piece. Okay? So I want you to think about this. So I'm going to draw these real quick so we can talk about this. So this one is the 35. Okay? And then this one is the 58. Okay? So, and then I'll label them here. So this is OB, A, O, B, A. Okay, so listen, we got 0.573. Okay, that came from a fraction, or that came from a comparison of two numbers. Okay, I want you to understand this. Sine of 35, is this side here bigger? Talking about this side, bigger or smaller than OA? Bigger. Don't look at my drawing.
Smaller.
It's smaller because if this is 35, what does this have to be? Has to add up to what? 90. So 55, right? The thing that we have to get through our head or just understand is that angles create sides. 35 degrees created this side. 55 degrees is bigger, should create a bigger side. So when I ask which side's bigger, this side's going to be the bigger side. We'll give it a B. This is the smaller side. Nope. Smaller the angle, smaller the side. This angle does not do anything for this side. This angle, right, it's the opposite. The angle creates the side. Angle creates the side. Okay, so the opposite of it, which is correct. Side opposite of angles are created by the angles. Okay, that's why 90 creates our biggest side, right? Because that's our biggest angle. Okay, so is everybody okay with that? So bigger the angle creates the bigger the side. Okay, so what I want you to see is, notice we're going to compare the signs here. Okay, so this is a smaller side over the hypotenuse. 58 though. Opposite of that is what? Is that the bigger or smaller? It's bigger now because the other one's going to be 32. So that's smaller. Bigger, smaller. Okay? So look. Bigger over hypotenuse, would you expect that to be a bigger decimal or smaller? So if I had 2 over 5 and then I took a bigger number on top and put 4 over 5, which one's bigger? So we're expecting this guy to be bigger for sine. Was it? Yes. You see what I'm saying there? I think we just did something we didn't do at the last class that I think is kind of groundbreaking in terms of understanding that concept. So hopefully that helps. So 35 is a smaller angle that creates a smaller side than 55. Therefore, the comparison of the small side to bigger side is going to be smaller than that because this side is the bigger one. Now look at cosine, the flip. This is what people really mess up with because cosine's flipped. So cosine is not over here, it's where? And this is our what? Bigger side. So when cos of 35 actually ends up being the bigger value because this is the bigger side. This is the smaller side for cosine. All right, I'm going to pause it for a second. I'll pause the video, take a second to digest that because I see. All right, so as we keep going through this, so that's why they want to show you these are the same setup. But then obviously they yielded different values. The different values come from essentially the length of sides. Okay, that's what creates the ratios. Okay, so diagrams below show triangles that are similar to the ones in the previous page in which 2 hypotenuses are equal to unit 1. So they're just saying that in general, we're going to be dealing with our hypotenuse with 1 today, just as an assumption. Okay, so don't worry about that, but that's what they're saying. All right. As the angle AOB increases from 35 to 58, explain using SOHCAHTOA why the sine ratio increases in value, but the cosine ratio decreases. Determine what happens into the tangent ratio. So we talked about this. So the sine ratio is opposite over hypotenuse. As the opposite side increases, the adjacent decreases, right? So therefore, the opposite side increases, then sine will increase. So the sine, having a sine with higher degree, so sine of a bigger degree creates a bigger ratio. That's what we just showed. We took sine of 35 and sine of 58, and the sine of 58 was a bigger ratio because as the degree increases, because that angle creates the opposite, our opposite increases. So cosine is the opposite over adjacent. As the angle increases, adjacent decreases. So smaller the angle. Sorry, pen's giving me trouble and I'm a little tired.
Does that say increases?
Yeah, increases, sorry. I'll write that too. Adjacent. Oh, yeah, you're right. I was getting ready for tangent. Thank you. So adjacent over hypotenuse. I was saying it in the words, though. As angles increase, adjacent decreases. So smaller the angle equals bigger the ratio. So example, cosine of 30 is bigger than cosine of 60. Okay, cosine of 30 is bigger than cosine of 60. You have to remember, if you're doing cosine from that angle, 30 doesn't create the cosine side. This is the part that you guys get hung up on. If I'm doing cosine of 30, this is the adjacent side. Does a 30 do anything to that? No, it comes from this guy, which that guy is now bigger. That's why the smaller this angle is, the bigger your adjacent can be. Okay, that's what causes cosine to be the reverse of sine. Okay, because cosine's the adjacent side, so it has to wait. How big's this angle? Oh, we want it smaller so that we can be bigger. Okay, so yeah. So example says cosine of 30 is a bigger ratio than cosine of 60. Because the smaller the angle, the bigger the cosine. Okay? All right, then lastly, tangent. Try to squeeze this in here with even poorer, like worse writing here. So tan is opposite over adjacent. So in a fraction, it's opposite over adjacent. Let's think about this. In a fraction, if you want the value to be bigger, do you want your numerator bigger or your denominator to be bigger? Numerator. So if we want the numerator to be bigger, then what do we want bigger? The opposite, so we want the actual angle to be bigger. Does that make sense? We just did much outside. So we want opposite comes from the given angle. Because again, if I say tan of 30, that's not very big. Because that's right here. That's creating that side. So we need, the bigger this is, the bigger your tangent is. So tangent, we want opposite to increase. Okay, so what this says is opposite increases and adjacent decreases. Therefore, we want tangent to be bigger for its ratio. So example, tan 60 is bigger than tan 30 for the ratio. So the only one that's really flipped is cosine, right? Sine we want bigger, tangent you want bigger. Cosine's flip of sine. So based on that, we'll do this example here in a second. I'll pause it for a second. You guys are writing. So let's see, bounce around here. Steph, did you already go?
Yes, I did.
Okay, Chloe, which one's bigger?
Sine 20.
Good. Sine 20, right? The bigger the sine, the bigger the opposite side. Okay, bigger the sine, the bigger the opposite side, which makes the bigger ratio. Good. Cosine, which one for cosine, Andrea? 7, right? Cosine's the opposite. The smaller the angle for where you're cosining gives you a bigger adjacent side. Okay, perfect. East, how about the next tangent one? Right, the bigger, right? Tan's bigger. Now here's tricky. Sine 80, cosine 80, or tan 80? Yeah, cos 80 is definitely out. Good job, Jake. Okay, let's look. Let's look. I think you guys are on the right track. Well, let's look here. I'm going to draw this the best I can. So let's do a 90 degree, and then we want 80. So it's going to be, let's make it actually a little more realistic. So it's going to be, okay, get that shut off. Okay, so there's 80. We'll say this is 10. Okay, that's what roughly that triangle would look like. Okay, so if we're doing, that's a pretty big side, yeah? 80. It's almost as big as the hypotenuse in reality. Okay? And then we have this is a really small side. Okay? So sine is going to be big over hypotenuse. But we know the hypotenuse is still what? Bigger. So we know this is less than 1. Do you guys understand that? Because this can be like 9 and this is going to be 10. They're close, but the top's still smaller. So we know that's less than 1. Cosine is going to be super small over hypotenuse. This is not even close, like Jake said. There's no way. Okay, and then let's look at tangent is going to be big over small. Do you see? Tangent's the winner because this number is bigger than this number. So it's going to be a number bigger than what? 1. Exactly. So this one wins. Tangent 80 is your biggest ratio there. Okay, what if we did, let's just right now out loud, what if we switch gears and let's say that we said we're doing sine, cosine, and tan of 20? Which one would be biggest? Yeah, the cosine would jump ahead because as we go back, sine and tangent both get smaller. Yep, 45 is the break-even point. Another great, you guys are doing awesome. Okay, 45, cosine and sine are equivalent because they're the same angle. Ah, good. Let's talk about that. So she said, what's bigger, sine 45, cos 45, or tan 45? Well, we know that cos and sine are exactly the same. So let's look at this. This is a great question. So we're going to draw a 45, 45. So these are, I'm going to put same. Is that okay? And we'll say this is 1 to make things easy. Okay? All right. So we know that, and we know that s is less than 1, right? Has to be. Okay? Okay, so if we do, let's do sine. So sine is going to be s over 1. So that's going to be just like 4/5 or something, right? It's going to be definitely s is smaller than 1. So it has to be something smaller. It's going to be like 0.8, 0.7. Okay? This one is going to be, for cosine, is s over 1 as well, which we knew that was going to happen. So these are equivalent, which that's what Calvin said. Tangent is s over s, which is 1. So tangent would be the biggest there. Because tangent is 1. Good. You guys are killing it. Good job. Okay, so let's go ahead and, all right, so what we're going to do is I'm going to get you down to example 5. We'll pause. I'll take a quick little break, and I want to cut this video into 2 videos. So we're going to do this example and kind of start this. I'll give you like a 2 or 3 minute break, and then we'll do the second part of the video, okay? So here we go. Use a calculator to determine the value of each trigonometric ratio. So do your calculator mode again. So go punch those out. So I think we are to Seth. So Seth, did I already do Seth?
No, you did these.
Oh, I skipped Seth. Okay, so we'll Seth, Bree, and Tegan, just for A, B, and C. So you just got to punch it in, is all. 4 decimal places. What'd you get there, Seth? 0.9876.
Oh, yes.
77? Okay. Tic-tac, we got it. Okay. East. Oh, not east, sorry. Bree? Say it again. Okay, good. Teague? 0.7193. You say 7193? Okay, so just playing with what we were talking about, guys and gals. Sine's really big ratio. Tan's really small ratio. What do you mean by small? Well, 0.2 is relatively small. Okay, cosine 44, almost in the middle. 0.7, so it's just slightly not, cosine, it's still smaller than 45, so it's slightly bigger. Okay, good. All right, so let's look at this. You're going to do the guess and check, and then I'm going to show you how to use your calculator to do it. Okay, so guess and check. I want you, if we know tan 35 is 0.7 and tan 58 is 1.6, find me what 1.2 is from guess and check. So try to guess and check. Just trying some. So like try 1040. So if I try 1040, I get 0.839. We're trying to find 1.2. 1050. 1.19. I'm really close. If we try 1051, I get 1.2349. So I'm really close here. It's between 50 and 51. So I'm going to try a couple decimals. Yeah, we're going to keep going though. We don't want to round. We want to get as close as we can. This is 1.21. What'd you say, Seth? Yeah, 50.3 is really close. And 1050.1 is really close as well. Okay, so these are all the ones that I just tried, but you can see we're zeroing in. It's right between 50.3 and 50.1. It's just guess and check. We're just punching things in our calculator. Okay, don't be overwhelmed. This method's obviously really time-consuming, so we're going to show you how to do it with your calculator to find it faster. It's actually just like algebra. What I mean by that is, let's just go through this. When you're solving, what's the opposite of addition? Opposite of multiplication. Opposite of squaring. Opposite of tangent, for example, is tan inverse. That's the opposite. Because you guys understand that inverse means 1 over, which means division. And so right here, they have the equation. When you have tan of a missing degree measure equals this ratio, we can figure out that degree measure by doing tan inverse to both sides. So you're going to put tan inverse, cancel, tan inverse 1.2 into your calculator.
How do you do that?
Second tan. So I want you to treat it like algebra. So you're doing the opposite. So in your calculator, it's right here, tells you it's second tan 1.2. See, it gives you the exact degree measure. Okay?
50.1.
Yep, 50.19. Yep, so almost 50.2, right? Okay, good. All right, so you guys, everybody got the 50.19. Or actually, let's do this real quick before the break. Do these 4 just using tan inverse, and then we'll stop. So you're just hitting sine inverse 0.3584. See what degree that is. Tan inverse cosine inverse. It says nearest whole degree, so nearest whole degree. Okay, so you remember, we're using these to find degrees, so think about it. I have to get to sine, cosine, or tan inverse to find different degrees, okay? So we are to Hassan, you got the first one. Okay, Colin, you have B.
Wait, how many decimal points again? Sorry?
Just around to the whole degree, so the whole number. Caden, you have C, and Jake, you have D. So whenever you're ready, just tell me.
I'm ready.
Yeah, what'd you get, Hass?
21.000.
So just 21, yep, just whole number. 21 degrees is the first one, that's good. What'd you get for B, Colin?
57.
57's good. Caden, you fire that in yet? To 106.
73.
Oh, yeah, 73.
Got you, man.
73? 73, good. And Jake, what'd you get for the 1/2? 30, perfect. All right, good. So we'll take a break there. Okay.